Kia ora everyone. Thought I'd make you a wee video in my at-home classroom that I've set up about linked genes, because it is a little bit of a tricky concept. And as you know, I love whiteboards, so I'm doing it on my whiteboard. So linked genes, if you just look at this section over here to start with, linked genes are genes that are on the same chromosome. So I'm going to use the same example as I used in the PowerPoint with freckles or no freckles, black hair or red hair. So if the parents have no freckles and black hair, and they're on the same chromosome, they're called linked genes. And then the other option would be to have freckles and red hair. They're linked because they're on the same chromosomes. They're going to travel together when they go into the gametes. So if you have this one, you'll also have that. It doesn't matter about independent assortment, which side of the equator they're on, because they're always going to travel together because they're on the same chromosome. So all the offspring should be the same as the parental types. If you've got black hair, you have no freckles, and if you have red hair, you have freckles. That's the only two options. When you do your dihybrid crosses, you actually are doing, you're always going to be doing ones that are independent of each other, so they're not linked, they're on different chromosomes, which means that you could have the allele for no freckles go into one gamete, and that could be paired with either the allele for black hair, or it could be paired with the allele for red hair. And then you can have your other chromosome with the freckles allele could be paired with black hair or with red hair. And so that's what you're working out when you do the first with third, first with last, and second with third, second with last. When you come up with your gametes for your dihybrid crosses, that's what you're doing. Because of independent assortment, those two might travel together into a gamete, or those two might travel together like that. And so you end up with the 4 different types, the 2 parental types and 2 recombinant types, because of independent assortment. Okay, and then you'll get a certain ratio for your cross. If you get the expected outcome from doing your dihybrid cross, and then they say here's the observed results, and the observed results are different to the expected ratio. Remember, for a heterozygote, the expected ratio is 9 to 3 to 1. So this is like the parental type that is the dominant one. So that is the black hair with no freckles, and this would be offspring that have red hair and freckles, and then these are the recombinants, so they're a bit of each. If you get something different to that ratio, the answer to the question is, it's because the genes were actually, instead of being not linked on different chromosomes and assorting independently, they were actually linked genes, but there was some crossing over. So they don't do all parental types, they still do a mix, but the numbers are a bit different. And so if we look over here, we can see that if you have, this was the parental types, but then if these two swapped and there was crossing over, you can get the recombination. And so you can get the mixture, but because it's crossing over is a bit random, the numbers will be different from what you would expect if they were assorting completely independently. One more thing about linked genes that cross over is the amount of recombinants you get will depend on how close or far apart these are to each other. So if I just take that one away and put up this instead. In fact, we don't even need both of them. Okay, so here's 2 versions. So remember, these are chromosomes, and there's a whole lot of different alleles all the way down at different loci or positions on the chromosome. Okay, in this scenario, they're quite far apart from each other, so it means crossing over could happen at this point, they could swap, could happen at that point, that point, that point. At any of those points, the 2 chromosomes could swap over alleles, so that the F becomes with the little b and the little f becomes with a big B, because this part here has, gone like that and come over here. So any of those points that could happen. However, if the 2 alleles are close together, there's much less chance of the chiasma where they swap happening to happen between the two of them. There's lots of chances it could happen all the way down here or all the way up here. Lots more than just the one chance that there is in between the two of them. So it could still happen, but the likelihood is, because they're so close together, that they'll end up either travelling with this half or that half when the crossing over occurs. I know that's a bit tricky. But anyway, that's my explanation of linked genes and non-linked genes and crossing over. So just remember, if they're linked, they're on the same chromosome, they'll be inherited together, you'll just get parental types. When you do your dihybrid cross, you're doing non-linked genes on different chromosomes, so they can assort independently. You'll get your expected ratio in your cross. If you get something different, the explanation is, instead of them being not linked, they were actually linked, but they crossed over, swapped over like that, and so you got a mix of parental and recombinant types, but the numbers weren't what you expected. And if there is lots of recombinants, then they were probably far apart on the chromosome, and if there weren't many of the recombinant types, then they were probably quite close together and therefore less likely to cross over. Anyway, I hope that helps and that you are going well in lockdown. I will do more videos on concepts that need a bit more explaining, and feel free to email anytime. Over and out.